Hi everyone. Let's talk about area. So what is the formula that is used to find the area of a rectangle? And why does it work? And what is the area of this rectangle? Well, the area of a rectangle, we use area is equal to length times width. Well, why does it work? Well, what we have here, if this is 3 inches, this would be about an inch, and then this would be another inch, and so on. And so we would actually have 3 rows, and then 5 inches. So if we come over here and measure 1 inch, and 2 inch, 3 inches, and 4 and 5, then we'd actually have 5 columns, and each column is an inch wide. And so each of these little squares would be 1 inch by 1 inch. And so we'd have 3 groups of 5. So we know that's multiplication. So it would be 3 times 5, which is, I don't know, we call this length and this width, which is kind of backwards from what we normally think of it. But we would have 3 times 5, which would be 15 squares. So we have 15 squares, and they're each 1 inch by 1 inch. And so we have 15 square inches. Okay, so why does it work? Well, it works because we divide this length into 3, and so we'd have 3 rows, and we divide this length into 5, so we have 5 columns, which creates squares that are 1 inch by 1 inch. So how do we measure the perimeter? What is the perimeter of this rectangle? And then how is perimeter different from area? Well, let's start with this last question. The area takes up the space inside the rectangle, and the perimeter finds the distance all the way around. So it would be 3 inches plus 5 inches plus 3 inches plus 5 inches. And so we have 2 of the 3 inches and 2 of the 5 inches. And so typically we see the formula 2 lengths plus 2 widths. And so the perimeter of this rectangle, we would have 5 plus 5 is 10. That's why I started with the 5s. So we have 10 plus 3 plus 3. 3 plus 3 is 6. So 10 plus 6 is 16. Well, if we use a formula, it's 2 times the length, which is 5, plus 2 times the width. So there's our 10, there's our 6, and so it would be 16. What units are we going to use? Well, we're just talking about the distance around the rectangle, and so that's just in straight inches. Area, moving and additivity principles. In this exercise, I want you to find a rectangle, something that we can cut up. What I'm going to do is I'm going to measure this, and this side is 6 inches. And so I'm going to label it 6 inches, and this one also is going to be 6 inches because it's a rectangle. And then this one's 4 inches, so 4 inches, 4 inches. And then what we're going to do is find the area. Well, the area is length times width, so 6 times 4. And what we could do is we could come up with 4 rows and 6 columns, and we could see the 24 squares. Okay, so now we're going to draw a diagonal. Okay, have we changed the area yet? I hope you're saying no. Okay, so now let's cut it in half. So, dun, 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 dun. And you don't have to be exact. I cut it right down in half. Okay. Have we changed the area yet? Okay, so what we want to do is, let's see, we've done this. So now we want to find 6 different ways to join a pair of identical slides of the triangles to create a new shape. Name each shape and compare all of your new shapes. How do the areas compare? And how do their perimeters compare? Well, if we want to talk about perimeters, well, one of the things that we could do is put them together, and I don't want to overlap because now we have a new shape. And what kind of shape is this? Oh, I hope you're saying a parallelogram. Okay, so what's the perimeter? Well, we know this is 6 and this is 6. Well, we have to find this length and this length. Well, what is this length? If we use the Pythagorean theorem, remember a squared plus b squared is equal to c squared. And that's when you have a right triangle. And we do have a right triangle here. I don't know if you can see the white on white, but we have a right angle here. And so we have a right triangle. So 4 squared plus 6 squared is equal to c squared. So 16 plus 36 is c squared. So what is that? 52 is equal to c squared. And so c is equal to the square root of 52. And so c is approximately 7.2111. Okay, and so on. Okay, so let's go back to this. And our perimeter would be 6 plus 6 plus 7.211 plus 7.211. And so our first shape is a parallelogram. And the perimeter is 2 times 6, because we have the top and the bottom, plus 2 times 7.2111, because that was the 2 slanted edges. And so what do we get with that? So that would be 12 plus 2 times 7.2111. And so we get 26.4222. Okay, and that would be in inches. Okay, so, but the area is the same. It's still the 24 square inches, right? Because we didn't do anything with the area. We just shifted it around. Okay, can you find 5 more? So let's pause the video there. Come on back when you find the 5 more. Okay, so let's find the other 5 shapes and come up with their perimeters. Well, first of all, we have this one, which we didn't talk about. And so this is a rectangle. The perimeter is 2 4s and 2 6s, so that's 20. And then we looked at this parallelogram, and the perimeter were 2 6s plus 2 of the 7.211s. And then we have this parallelogram, and we have 2 4s and 2 of the 7.211s. And then what we need to do is flip one of these. So let's flip this one like this. And so we need to match them up. And so if we match the sides of length 4 up, we would have a triangle. And the perimeter would be 2 6s and 2 of the 7.211s. And then if we rotate and have the 6s match up, well, then we would have another triangle. And the perimeter would be 2 4s and 2 of the 7.211s. And then if we rotate it again, we have something that looks, I don't know, it's quadrilateral. And it's something that looks like maybe like a kite. We have 2 4s and 2 6s. And so I ended up with all of these. Okay, so the next thing we're going to talk about is finding areas. And we're going to do that in a couple different ways. We're going to subdivide a shape. So we're going to have some kind of irregular looking shape. It's not going to be a straight rectangle or triangle or anything like that. But we're going to have this irregular shape and we can subdivide it. In other words, we could cut it down here and have 2 rectangles. Or what we could do is create a big rectangle like this. That would be 6 by 10. And then take away what's missing. So we would take away this rectangle that's 2 by 5. We could also move and reattach. So what that means is I'm going to look for 2 lengths that are the same. So here's 5 and here's 5. So if I cut this down here and take this shape and plop it on top, and so it would come up here like this. So this is now up here. And so what is this? 4 by 5. So this would be 4 by 5. And so now we really have 10 by 5 because this is moved up. And so we could find the area that way. Or what we could do sometimes, this doesn't happen very often, but we could trace this, make another copy, and put the 2 pieces together like a puzzle piece and have it form a great big rectangle. And so if I make another copy, and so what I'm going to do is take this and rotate it and stick it up here. So this would be 6, because this rotated over here. This would be 4. This would be 10. And then this 5 would match up here, and this 5 would match up here, and the 2 matches up with itself. And so what we would have is a 10 by 10 square. But then that's actually 2 copies of the same thing. So we'd have to divide by 2 to get 50, which is the area of this one. So 50 square units. Okay, so let's go on, take a look at the Finding Areas worksheet and see what you can do with subdividing it, finding the big rectangle and taking the little one away, the moving and reattaching, and also making 2 copies, which I just showed you. So go ahead and do that, and then come on back.